MWD and LWD systems have fulfilled a long-time dream among industry professionals by making it possible to monitor and control operations even as drilling is taking place. Examples of what we can now do continuously and in real time include measuring drill bit position and trajectory, monitoring penetration rate, actual weight on bit, downhole torque and drag, vibration and other drilling parameters, computing pore pressures and getting an early warning of potential overpressured zones, detecting and correlating geologic markers and formation tops, and evaluating formations even as they're being drilled. These systems are modular and can be run with various sensor combinations according to the well plan requirements. MWD tools operate by creating pressure pulses in the mud column in response to inputs from the various sensors. Depending on the type of tool, the pulses may be positive, negative, or continuous. These pulses are converted into electronic signals which are processed and displayed at the surface. The basic components of the MWD instrument package shown here include a battery-powered pulsar module, which in this case employs a continuous mud wave transmission, a sensor module containing triaxial inclinometers to measure drift and triaxial magnetometers to measure azimuth, along with temperature and pressure sensors, and an electronics module. This particular tool, together with its accessory modules containing the batteries and centralizer, is run inside standard non-magnetic drill collars. Logging while drilling, or LWD tools, operate on basically the same principles as conventional wireline logging tools. The dual resistivity device shown here contains a gamma ray tool and two sets of transmitters and receivers to provide shallow and deep resistivity readings. This compensated density neutron tool measures density and neutron porosity in a manner similar to that of analogous wireline tools. When drilling with a mud motor, these particular tools are run above the motor assembly, in other words about 30 or 40 feet above the bit. In some applications, such as drilling in very thin dipping pay zones, this information gap between the bit and the tool could be critical. For this reason, systems have been developed that allow measurements to actually be taken within a few feet of the bit. Although LWD tools work in generally the same manner as conventional logging tools, keep in mind that tool responses will most likely be different in highly deviated wells from what they would be in vertical wells, and that these responses require special methods of interpretation.